magnetic field which magnetizes a substance is called the magnetizing field. Now we have seen that a circulating electron in an atom has a magnetic moment. We have already discussed that. A circulating electron in an atom has a magnetic moment, and we also deduce expression for that magnetic moment. In a bulk material, these moments add up vectorially and they can give a net magnetic moment which can be non-zero. We have already deduced an expression for the magnetic moment of an electron revolving around the nucleus. We have deduced that. Now, every bulk material consists of molecules and atoms, right? And atoms has electrons, and that electrons are circulating electrons, and each circulating electron has a dipole moment. So there will be huge magnetic moments, right? Now these magnetic moments add up vectorially and they can give a net magnetic moment which is non-zero. The degree or extent to which a substance is magnetized when placed in a magnetizing field is called the magnetization or intensity of magnetization. Do you get it? Today we are discussing different terms which explain the behavior of magnetic material, right? First, we have discussed magnetic flux and flux density. Now, second term we have told magnetizing field. Third term we are going to discuss is the intensity of magnetization. What is intensity of magnetization? What we have got? Each and every material has dipole moment, right? Now, if we place a magnetic material in a magnetizing field, then that magnetizing field produces a magnetic net dipole moment, net magnetic dipole moment in the substance, right? When we place a magnetic material in a what? In a magnetizing field, then the degree or extent to which a substance is magnetized is called the intensity of magnetization or only magnetization. The magnetic dipole moment per unit volume, of the substance is known as intensity of magnetization. This is the quantitative definition, and first we have we give the qualitative definition of intensity of magnetization. Intensity of magnetization is the degree or extent to which a substance is magnetized when it is placed in a magnetizing field. Now we say that the magnetic dipole moment per unit volume of a substance is known as intensity of magnetization or magnetization vector. Clear? If M net be the net magnetic dipole moment of the substance and V is the volume, then intensity of magnetization capital M is equal to M net by V. If M net is the what? Net dipole moment of the substance, and V is the volume of the substance. intensity of magnetization. Intensity of magnetization or only magnetization vector. Now you can write this as mnet. This mnet can be written as m into 12 or qm into 12. Where qm is the what? Qm is pole strength and 12 is length of the material, that is magnetic length of the material, that is the distance between the two poles. Now if we write this here, then you can write qm into 12 divided by, this can be written as a into 12 or alpha into 12, whatever you can write. A is the cross sectional area of the substance and 12 is the length of the substance. This 12 cancels out and you can write this as qm by E. That means intensity of magnetization is equal to pole strength per unit area of cross section of the substance. Intensity of magnetization is equal to the pole strength per unit area of cross section of the substance. Actually, this intensity of magnetization, that is magnetization, is a vector quantity with dimension. What is its dimension? It is a vector quantity and its dimension is, what will be its dimension? I into L. And this is L square. Therefore you can write L to the power minus 1 I. See here. Qm into 12. What is this? This is magnetic dipole moment of a magnet.
Yes, sir.
And that is equal to I into A. What is I into A? I is a magnetic dipole is equivalent to a what? Current carrying loop. And magnetic moment of a current carrying loop is current into area of the loop. Current into area of the loop. Right? Therefore you can write Qm is equal to I into A divided by 2L. Therefore dimension of Qm is I is I and A is L square and 2L is L. Therefore L into I is the dimension of pole strength. Do you get it? Now we put here pole strength and this is area. Therefore L to the power minus 1 I is the what? Dimension of intensity of magnetization. Therefore, what will be its SI unit? Its SI unit is ampere meter inverse. Ampere meter inverse is the SI unit. That is ampere per meter is the SI unit of intensity of magnetization.